Hi everybody, in this video I'm going to show you how to assemble the IR remote DIY kit and use it with the quantum system. So let's get started. This is not just another remote to control your TV. The IR remote DIY kit includes a series of buttons and an IR emitter that can be used in conjunction with the quantum system to create the ultimate universal remote. This DIY kit will allow you to control any component connected to the quantum system, countless IR devices, and supported integrations with other IoT platforms. What you program your remote to do is up to you. This DIY kit also uses multiplexing technology. Multiplexing is a method by which multiple analog or digital signals are combined into one signal over a shared medium. The idea is to reduce the amount of connections to a receiver by combining several signals at several distinct value ranges into a single medium. In the case of the IR remote, multiplexing is used to distinguish a series of push buttons based on the analog value that is received. So instead of having a single GPIO terminal for each of the 12 push buttons, we are able to reduce the amount of GPIO terminals used to one per row by determining the different analog values given by each push button in a series. Before we get started on assembling the IR remote, I would first like to show you our documentation page for this product. This page will provide you with all the information regarding this product, such as description of the kit, projects we have made with the kit, and most importantly, the designators to tell you where to solder each component. I'll have the link for this page in the description below, or you can also scan the QR code found on the packaging. Now let's solder those components onto the PCB. I'll be following the designators found on the documentation. For example, where it says R1 on the PCB, I'll place the resistor designated as R1 in the documentation and solder it to the board. So once you're done soldering together the IR remote, this is what it'll look like. So you can see here we have the IR emitter, the LED indicator, all 12 buttons, the pin headers, and the battery holder. You also notice that there are a few pieces that are left from the DIY kit packaging. There are a couple brass standoffs and some screws for it. We're going to be using these to mount a naked builder-based client to this IR remote so we can control it. So to do that, what you'll need to do is take a builder base like this one and take off the blue shell that is attached to it. There is a screw on the back side. Once you unscrew that, a couple of the mounting screws inside the builder base, you can take it out and it'll look something like this. It'll just be a PCB with the junction terminals on them. So once you've done that, what we're going to do is take our IR remote again, and we are going to connect the brass standoffs to the two screw holes on the PCB here. So now you can see that I mounted the brass standoffs to the IR remote. Before I mount the builder base to the bottom of the IR remote, what I'm going to do is connect the wires to the associated GPIO terminals, 3.3 volt terminal and the ground terminal, because we'll be connecting those to the pin headers on the IR remote. And if I try to connect the wires after I mount the builder base, and as you can see, the top of the junction terminals with the screw holes is blocked by the IR remote, so we won't be able to wire in those jumper wires, so we have to do it beforehand. So let's go ahead and do that. I'll be bringing in 4 male to female jumper wires for the GP terminals, and then 2 male to female jumper wires for the ground and 3.3 volts. So let's go ahead and connect them. I'll be following this schematic here. So if you can, try to find some jumper wires that are already still kind of connected together. It'll make it a little bit cleaner. I have found where there's only a couple that are still attached together, but if you don't, that's totally fine. So to get started, I am going to connect the first male to female jumper wire to GP0 on the builder base. And then for the second one, we'll put it to GP1 on the builder base. And then we'll also do GP2 and GP3 on the builder base. And then lastly, GP4. So for this, we're going to have row 1 be connected to GP0. We'll have row 2 connected to GP1, row 3 connected to GP2, and row 4 connected to GP3. And then GP4 is going to be connected to the LED pin header on the IR remote. And then now we'll connect this male to female jumper wire to 3.3 volts on the builder base. And then lastly, we'll attach the ground male to female jumper wire to the ground terminal on the builder base. And here we go. Now we have all the jumper wires connected to the builder base. Let's go and bring in our IR remote. To make this a little bit easier, it's best to feed the wires through the little gap in the PCB like so. And once you have done that, we'll mount the builder base to the IR remote. What we want to do is make sure the junction terminals are facing the IR remote here. And then the micro USB connector on the builder base is facing the back of the IR remote, just like this. And then I'll just line it up to the screw holes on the brass standoff and then screw them together. So there we go. Our builder base is now mounted to the IR remote. Let's go and connect the jumper wires accordingly to the pin headers. So on the IR remote, you'll see it's laid out button 4, button 3, button 2, button 1, then LED, ground, and then 3.3 volts. Button 4 refers to the top row here. Button 3 refers to the second to the top. Button 2 is the third to the top. And the bottom row is button 1. And the single LED pin header goes to the two LEDs up top, the IR emitter and the LED indicator. So for the wire that you connected to GP0, go ahead and connect that to where it says button 4 on your IR remote. And then the one that's connected to GP1 on your builder base, connect it to button 3 on your IR remote. And then the one connected to GP2 on your builder base will go to button 2 on your IR remote. And then the one for GP3 goes to button 1 on the IR remote. And then the one that's connected to GP4 will go to the LED pin header on the IR remote. And then connect your ground and 3.3 volts. And there we go. Now we have connected the builder base to the IR remote. Now let's go ahead and take a CR2450 coin cell battery. You'll have to get this yourself. And then put that into the coin cell slot on the IR remote here. And then lastly, this is very important, make sure you check the bottom side of your builder base in the switch here. Make sure it's switched to USB. We're not using battery power. If we were, we'd be using this, but we're not. Keep it on the USB option on the switch. And then once you have done that, you can flip the back switch on the IR remote to turn it on. And then you'll see your builder base light up. So once you have done that, let's go over to the Q server and do the rest of the setup. So here we are on the Q server. The first thing we'll need to do is pair that builder base that we connected to the IR remote kit. So let's go over to the clients tab. We'll go to the unpaired tab. And then for that new builder base, we'll go to actions and then select pair. Once the builder base is paired, we'll click the setup button and then give it a name. I will name it IR remote. And for location, I'll do living room and then click save. Once you have done that, the next thing to do is to create the firmware file for this DIY kit. Keep in mind, we'll include the app used in this video and the firmware file for this DIY kit in the library section of the Q server, so you can go there to download them, or you can follow along now to learn how to create the firmware file yourself. So to do that, we'll go to the firmware tab and then click create new. And then I'll name this IR remote DIY kit. And now let's add the hardware. We'll click add hardware here. So since we're using multiplexing for this DIY kit to reduce the amount of GPIO terminals we need to use, we're not going to be adding button hardware to this firmware file. Instead, we're going to add one analog in hardware for each row of buttons on the remote. So I'll select analog in, and this one I will name row 1, then click add hardware. I'll go ahead and just add the next row, name it row 2. You can see the analog in type is already in. Then click add hardware, do row 3, and then row 4. And then lastly, we'll have to add the LED hardware for this. Both the indicator LED and the IR emitter LED are on the same GPIO terminal. So we'll just add one hardware for that. That's going to be the IR emitter hardware. And then we'll just name it IR emitter. And then click add hardware. Now let's go ahead and assign these different types of hardware to the certain drivers and GPIO terminals that are being used. So for row 1, we are going to select the GPIO driver. And for the pin, this is the one that you connected to the pin that says button 4 on your IR remote. So I have button 4 on my IR remote connected to GP0. So I'll click GP0. Granularity, I'll keep at 50. And then for row 2, the driver would be GPIO as well. And then for the pin, that's going to be tied to button 3 on the IR remote. So I have button 3 connected to GP1 on the builder base. And I'll select that. And then row 3, again, driver would be GPIO. And for the pin, that's going to be connected to button 2 on the IR remote. And that I have connected to GP2 on the builder base. And then row 4, the driver will be GPIO. And then the pin, that's going to be for button 1 on the IR remote. And that's connected to GP3 on my builder base. And then lastly, for the IR emitter, I'm going to select the driver IR emitter. And then for the pin, that's going to be the one connected to where it says LED on your IR remote. And they'll be connected to GP4 on my builder base. All right, now we have created the firmware file. We'll click save. And then now I'm going to upload that firmware file to the builder base that we named IR remote, and then click upload. So while that's uploading, let's go ahead and take a look at an example app I put together where it'll give you more information about how you can create an application and different ways to utilize the IR remote's capabilities. So I'll just quit out of the notifications there. I'll go to the apps tab, and then I'm just going to that example app and then click edit. Don't worry, this will be included in the QServer library for you to download. I'll also have it in the documentation for this video. So this example app, it provides you with plenty of common objects here next to all these other code objects, which will guide you step by step on how to create an application with the IR remote. It starts on how to find the analog values for each button per row, and then how you can distinguish those in order to know which button is being pressed using the number between code objects here. And then it goes into two different options on how you can create a way to send out the IR codes through the IR emitter. So we have one option where you can use the infrared service on the Q server, and then you have drop-down menus on your dashboard once you run the app where you can select the brand, the device, the configuration, and then the desired action under that configuration. And then it will store that code into a static string object. And then once you push a button, that will trigger the static string, send it to the IR emitter, and then it'll send it out to whatever device you're trying to control. And then the second option, it basically bypasses all of this here. If you already know what your IR codes are, you just store it in the string port of the static string object here. Then when you push the button, it will trigger it, send it to the IR remote. And then I also included some pros and cons on why you would do this guy versus that guy and vice versa. And then lastly, I have provided a example application where it shows you the first row performing 3 IR based actions that will send out the IR codes to the emitter. And then the second row of buttons on the IR remote can be used for various other actions like turning on the hue bulbs or the motorized shades or just another stored IR code in the static string. The possibilities on what you can do with this IR remote is almost endless. You can create scenes for lights. You can customize the motorized shade based on like how I did the motorized shade project on a different video, which you can check out on our channel and so forth. But I'll have this in the library so you can download it yourself and go through it. But for now, why don't we go step by step and learn how to do the initial setup for this IR remote in an application. So I'll just click Save App. We'll return to my apps. Let's go ahead and create a new one. I'll name this IR Remote Test App. Click Create. Now, the first thing we'll need to do is bring in 4 analog and hardware objects, 1 for each row of the IR remote. And then after that, I need to bring in 4 text interface objects, 1 for each analog in object. And what this is going to do is allow me to read the analog values that are being sent to the system based on each button I press on each row of the IR remote. We'll clean it up a little bit. There we go. Let's go ahead and name these text interface objects as well so we know which one's which when we are on the dashboard getting the analog readings. So the first one will be row 1, this one will be row 2, third one will be row 3, and then for the last one we'll name that row 4, and we'll click Save Properties. And then we'll also name them accordingly for the analog in objects. This will help us distinguish them in the mapping process of the app. So this one will be row 2, row 3, and the last one will be row 4. And then now let's save the app and then return to my apps. And we'll scroll down to the test app, click the play button. Now let's map all those hardware objects to the hardware files that we created in the firmware. So for row 1, we'll map to the row 1 hardware file on the IR remote builder base. Row 2, we'll connect to row 2. And then row 3, we'll connect to row 3. And then row 4, we'll connect to row 4. And then we'll click Save and Run. Now once that app is running, we'll go to the dashboard, go to the IR Remote Test app. And then now you can see we have each text interface object here, rows 1 through 4. Now I have my IR remote in my hand here. Now if I press that first button on row 1, you can see it gives us an analog value. If I do row 2, you give us one, row 3, row 4, and then see I'm back on row 1. Now if I press the second button on row 1, you can see it's giving us a different analog value. So the first button is 2700 roughly, the second one is 2000, and then the last one is around 1200. So to keep track of these different analog values, what I did was I created a little grid here where we'll write down the different values, and then we'll go back into the app, add in the number between code objects, create thresholds that will help us distinguish which button is being pressed from that row. So for the first button on row 1, on the left side, is at 2729. So I'll type in 2729. Now that middle button on row 1 is 2006. Type in 2006. And then for the very right button on row 1, it's at 1262. So now that you get the idea, I'm going to go ahead and fast forward through the rest of this just to make this quicker. $12.59. Okay, so there we go. We have found all the analog values for each button for each row of the IR remote. So as you can see, the values for each button on the rows are roughly the same amount, which is good. Now, when we go back to the app, we'll create thresholds using the number between code object. Then that will help us distinguish each button for the IR remote. So here are back on the apps tab of the Q server. I'm going to pause our application and then go to edit. Now we can go ahead and delete our text interface objects. We'll keep these. Now we are going to need the number between code object. We'll need one for each button basically. So there'll be 3 per analog and hardware objects. We'll move those out of the way. 1, 2, 3. So looking back at our little chart here, we have found for row 1, button 1 was around 2700, button 2 was around 2000, and button 3 is around 1200. So we don't need exact analog values for this necessarily. We'll be creating thresholds plus or minus 200 from this number. That way it'll always land inside and we'll know which button it is. So for this first row, we are going to start by naming the objects so we know which one's which. We'll say B1 with roughly an analog value of 2700. And then we'll click Save Properties. We'll name this one B2 for button 2. And then that one had roughly around 2000 for the analog value. And then we'll click Save. And then for the last one, this will be B3 for button 3. And it had an analog value roughly around 1200. And then we'll click Save Properties. So those are just the names. Now what we need to do is connect the value port of the analog in to the value port of the number between code object. And then remember, this is really important. You have to turn that value port, click it, and then turn on the trigger option for that port, and then click Save Properties. Now what that will do is every time this object sends a value to this code object, it'll trigger the entire sequence. If you don't do that, what's going to happen is it's going to send the value into this port, but it's not going to be triggered and it's not going to do anything. So once you've done that, let's create the threshold for the analog value for that button. So we'll click the min port here. Now I typically like to do a plus or minus of 200 from the rough estimate of the analog value for that button. So for the minimum here, we'll type in a value of 2500 and then click Save Properties. And then for the max, we will do a value of 2900 for that and then Save Properties. Now let's go ahead and do that for button 2 here. Remember, we'll have to drag the line into the value port, and then for that value port, we'll have to turn on the trigger and then click Save Properties. And then for the min, for this one, we will type in a value of 1800 and then click Save Properties. And then for the max, we will type in a value of 2200 and then click Save Properties. And then now we'll do button 3, put into that value port, turn on the trigger for that value port, click Save Properties. And then for the min, we'll put in 1000, click Save Properties. And then for the max, we will put in 1400 and then Save Properties. Now we can clean this up a little bit just so it looks a little bit nicer. So there we go. By doing this, we're now able to distinguish which button is being pressed in row 1 of the IR remote. So once you have done that, you can attach whatever you want this button in particular to trigger and then go from there. But I'll go ahead and complete the last 3 rows. Now the nice thing about this remote is the values are roughly around the same as you saw with this little chart here. so we can still use the same min and max thresholds for each number between object here. And then we can take it, highlight it, copy it, and then paste it. And we'll just drag it down here. And then we'll connect the value port of the analog in hardware object to the value in ports of those new number between code objects. And then just double check under the value port that the trigger is turned on. And then you can just go ahead and clean it up and then continue to the next row. Okay, now we have completed the second row. Now that you get the idea, I'm going to go ahead and fast forward and complete row 3 and row 4. So now we have distinguished each button on each row of the IR remote. To test to make sure we have done this correctly, what we're going to do is bring in switch interface objects, one for each number between code object that when we push the button will turn on, and we'll see it turn on the dashboard. So here we'll take the out port of the number between, we'll connect it to the state in port of the switch, and then we'll name this object R1B1. And we'll also name the dashboard label R1B1 for row 1 and button 1, and then click Save Properties. And then for the second one here, we'll do the same thing. However, we are going to name this R1B2, row 1, button 2, and then also do it for the dashboard label, and then click Save Properties. And we'll do it again. We'll name this one R1B3. We'll label it R1B3 and then click Save Properties. Now that you get the idea, I'm going to go ahead and fast forward through the rest of this. So there we go. Now we have a switch interface object for each button on the IR remote. As you can see, they're all named accordingly. They kind of sound like Star Wars droid names like R2B2 here. But once you've done that, let's click Save App. And then we'll go to Return to My Apps, go down to that test app, click the play button, and then make sure you have mapped all the hardware objects to the hardware on the builder base. Click Save and Run. And then now when I go to the dashboard here, I'll go to that test app. Now you can see all of the buttons here. Now when I press that first button on row 1, you can see that the switch turned on, and then I released it. Now for button 2, now that turns on. Now button 3, that turns on. Now for row 2, button 1, button 2, button 3, row 3, button 1, button 2, button 3. Now row 4, button 1, button 2, button 3. So there we go. Now we know that each button works. We distinguished it. It sends out a digital out signal. Now we can attach whatever type of action we want to those number between objects, and then it will trigger that action to perform using the IR remote. So to demonstrate this, I'm going to show you a demo app that I put together that's going to control a variety of different stuff in my living room, including my IKEA motorized shades, my Hue bulbs, my Samsung TV, my Marantz receiver, and my Xbox. And it will also include scenes where I push one button and then it'll control a variety of different hardware and perform a specific action for each one. So let's go ahead and check it out. So here we are in my living room. What we'll be doing is using the IR remote DIY kit and the associated interface objects on the dashboard for the app to control various actions on my living room setup here. What we'll be doing is playing and pausing the movie that I already have going on my TV. We have Philips Hue light bulbs in the lamp, so using the gateway, we'll be able to toggle those on and off. I also have the IKEA trad-free motorized shade up there. We'll be able to roll those up and down as we please. And then lastly, I have programmed a scene to one of the buttons, and what the scene is going to be is like an intermission mode. So when I push that button, it's going to pause the movie that's already running, turn on the lights to 20% brightness. Now that way it will let me go up, do my business if I want to go make more popcorn, go use the bathroom, or so forth. And once I've done that, I just push the button again, lights will come off, and the movie will play again. So to start, let's go ahead and roll down these IKEA shades. I'll just take my remote. Now you can see that they are rolling down. Now let's go ahead and roll them up using the shade portion of my app. As soon as I click it, you can see that the shades are now rolling back up. Perfect. Now let's go ahead and turn off these lights and start the movie. So I'll turn off the lights. I'll click the play button. Now let's say I want to get up and make some more popcorn. I'll click that intermission scene that I made. So I'll click that button. Now you can see the movie is now paused. The lights are now at 20% brightness. And then now when I push that button again, lights go down, and then the TV plays again. So let's go ahead and turn these lights back on. I'll go ahead and pause the movie. So that's how you can use the IR Remote DIY Kit with the Quantum System to create your own universal remote to control a variety of things besides just your TV. You can control lights, shades, so forth. The sky's the limit. So make sure you check out the links in the video description below for more information about this product. And I hope you enjoyed this video. Thanks for watching.